two ways to record objects: by the quantity you have, how many, or the mass, how much does it weigh. They are not related to each other, as you know. But when we include the quantity of moles, it becomes confusing for many, many students. Okay? You already know some quantities, such as a dozen and a pair. There are numbers that are associated with these, and you know exactly what those numbers are. It's not a discussion. It's never 11.5 or 12.5. It's never 1.5 or 2.5 or 3. It's always a pair. Now, they are not related to each other. A dozen eggs doesn't weigh the same. A dozen eggs does not have the same mass as a dozen, say, donuts. Okay? They don't have the same mass, or at the very least, if they do have the same mass, it's a coincidence. You know that to be true. Now, within science and chemistry, counting things by the dozen or the pair is just not enough. We need a new quantity to count atoms, and that is the mole. And the mole is a vocabulary term to be absorbed, and it stands for a number 6.022 times 10 to the 23rd. You could have a mole of anything. You could have a mole of eggs. You could have a mole of donuts. You could have a mole of car tires. You only really use this term because it's so large when counting atoms. Now, each atom doesn't weigh the same. You know, these circles are just meant to represent the nucleus and electron shells of hydrogen, carbon, and iron. It's no surprise that they wouldn't weigh the same. If you have a dozen hydrogen atoms, it would not weigh the same as a dozen iron atoms. You still have 12 and 12, but they don't weigh the same. If you had 1 mole of hydrogen atoms and 1 mole of iron atoms, again, they would not weigh the same. It would be the same quantity, but not the same mass. The question is, if you have 12 grams of carbon and 6 grams of hydrogen gas, which has more atoms? Now, atoms are so freaking small. So there's going to be billions of billions and billions of atoms in 12 grams of carbon. There's going to be billions and billions and billions of atoms in 6 grams of hydrogen gas. But which one has more atoms or a greater amount of atoms? The periodic table, in the bottom square of each box on the periodic table, there's usually a number that unfortunately doesn't have units on it too often. And the units of those numbers at the bottom of the periodic table will always and ever be grams per mole. So what that means is that if you have a quantity of carbon atoms, i.e. 1 mole, it'll weigh 12 grams. And remember, 1 mole is 6.022 times 10 to the 23rd. If you have 1 gram of hydrogen atoms, then you must have 6.022 times 10 to the 23rd, this quantity. 12 grams of carbon in our scaffold. The number from the periodic table, I'm just going to round it to 12 grams per mole. Twelve divided by 12, 1. We have 1 mole of carbon, which is the exact same thing as saying 6.022 times 10 to the 23rd atoms of carbon. Remember saying at the very beginning how 1 dozen, I don't need to tell you what that number is because you already have dozen internalized. Now you need to internalize what mole is. This number. So 1 gram of carbon equals 1 mole of carbon. Hydrogen gas, H2. H2, so by looking up the formula on the periodic table, there are 2 hydrogen atoms. Three moles of hydrogen gas. Instead of saying 3 dozen, 3 moles. 1 mole versus 3 moles, it's easy to see which one has more atoms. Now the confusing part is, but wait a minute, there is less grams. How do we have more quantity of it? Okay. Remember at the very beginning, 6 dozen eggs doesn't have to equal the mass of 6 dozen donuts. 6 dozen paper clips is not going to equal the same as 6 dozen eggs. Be careful about counting units and mass units. Thank you.